Okay, thank you everybody for joining us today. We're joined also on a live stream at the moment with people that are also joining and participating in our events. My name's Theodore Sparopoulos. I have the pleasure of welcoming everybody today for what is day 2 of a 2-day event that we call our Phase 2 thesis reviews. This is basically the conclusion of a 16-month journey for the students that come to us from pretty much everywhere in the world to the AA to basically explore architecture in an expanded sense, to see and engage in a form of design and research that is really trying to look at a series of challenges in the world and try to operationalize them within the context of computation, prototyping, manufacturing, gamification. There's a host of a lot of subjects that many of you have seen over the first day and that will continue today, finding form basically in 4 parallel research labs within the DRL with Patrick and his team working on issues of the metaverse and kind of exploring that and looking at learning environments as a form of a new Bauhaus in a kind of post-COVID age. We have Sajay Bushan and his team that are working on the subject of gamification, looking at settlement design, the city, and trying to really problematize different forms of participation and time-based development with various stakeholders. We have Pier Andrea with his team that are working on subjects of mobility, trying to challenge the fixed and finite orthodoxy of thinking about buildings and looking at mobility and transformation as a response to some of the challenges, both climatic, social, and political today. And the studio, my name is Theodore Sparopoulos, that I work with my team that are looking at the subject of the elemental, or what I've called the elemental, which is looking at phenomenon as a form of technology in the pursuit and motivated by sustaining life. The way that research is somehow conceptualized within the DRL is really over 3-4 year umbrella agendas. These agendas serve to really offer a kind of framework for us to basically respond to various challenges, from urbanism to prototyping in terms of detail, to looking at microbiology or different forms of synthesis of quantum physics, other things, whatever subject, anything could be architectural in the DRL. But architecture with a capital A is basically where we're motivated with trying to apply a lot of the research. So you'll see basically years of experiments, prototyping, demos, online kind of metaverses, which are all in a way trying to make a lot of the work open and accessible. We've been streaming these juries for over 15 years as an attempt to really allow people a window into the lab, but also to see that the event, both yesterday and today, is motivated with conversation and the idea that architecture really brings us together to really respond to a lot of the challenges of today. Without any further ado, I would like to thank the critics who are joining us. We have, for everybody, made a mini site with all of their distinguished accolades. We're always very thankful for the generous time that people give to us. So we want to thank them in advance today for participating with us in these conversations and helping us shape, let's say, the next year's worth of research. At the conclusion of today's event, we will also have a keynote speaker. This year it's Marta Malay Alamani, who's going to be talking about circular economy and circular forms of production. And the schedule for today is basically we'll be looking at 3 teams. In the morning, we'll take a break for lunch and continue with 3 teams in the afternoon. So with that, we'd like to thank everybody who's joined us again for today. We hope that the conversation will be as engaging and building on a lot of the things that we touched on yesterday. And we'll pass it on to the first team, which is from Pier Andrea's studio, Algenator.
Hi, good morning, everyone. We are team Algenator from Pierre Andrea Angie Studio. The studio brief explores design strategies for both mobility and habitation, with a particular focus on environment and meteorological entities. The studio brief looks to identify opportunities for meaningful contributions aligned with the society needs by rethinking infrastructure as dynamic and adaptable. We explore collective occupancy strategies that emphasize self-sufficiency, adaptability, resource economy, and behavioral intelligence. The thesis responds to the idea of giving back to nature in a world where we build houses using a combination of natural man-made materials and causing harm to the environment by polluting it in various ways. One of the design drivers of the project came to look at pollution in coastal cities. The main driver being deployed to tackle air pollution is microalgae, using case studies as a way of understanding performance measures and effective designs. The thesis explores the possibility of situating the project in a neglected urban fabric in the city of Mumbai. The less developed area comparatively allows us to develop it further and give it upcoming and develop communities in the eastern waterfront, hence allowing the area to have deployable units and also allowing better access to the main city with the help of connectivity through ports which are available on the shore for us.
We chose host cities as an environment of interest due to the current critical dilemma occurring in the region. In order to address urban flooding and a city coastline, that was the main concerns. Project aimed to find a solution by occupying the nearby bodies of water, creating a self-lighting and an adaptable water-based urban community. We started by looking at the rise in sea levels. In the coming years, we looked at data, analyzed the significant risk that is caused by the rising sea levels. We took particular interest in cities like London, New York, Seoul, which are in danger of rising sea levels in the coming years. The data suggests that in the coming times, these cities will be posed by the risk of rising sea levels. The thesis also responds to the idea of giving back to the nature, as we had mentioned in our statement, due to the rise in pollution. These are the consequences that arise due to the pollutants like carbon dioxide contributing to the global warming and climate change by enhancing the greenhouse events, and PM 2.5 particles, which can cause respiratory issues. We look to analyze the carbon emission in previous years to see the devastating impacts that these emissions are having on our planet. We also looked at the PM 2.5 emissions over the past couple of years to see the increase in amount of pollution that there is. PM 2.5 contributes to poor air quality, which diminish the quality of life and stain healthcare systems. These particles can damage ecosystem by affecting soil and water qualities, harming plants and reducing the visibility through hazes. We quantified the data we were studying into maps and looked at the emissions over the entire globe. We looked at the top polluted cities in the world, and then with the brief, we had defined for ourselves of tackling air pollution and looking at the rising sea levels. We added the filters of looking at polluted cities near coastline. We studied the data of these cities, such as polluted areas and density and air pollution qualifications. Based on the data collected, which was Mumbai, we chose Mumbai as our particular city of interest, and we did basic site analysis, which we looked at wind speed, population density, the rise in sea levels due to the monsoon, the loss of land due to the rising sea levels, industrial traffic, and pollutant levels. Over the map, we also looked at the access of smaller ports and larger ports. We looked at the potential that the site brings to us, such as northeast winds that blows towards the proposed site, the quality of air pollution and the increase in Mumbai. The quality of air have been the quality of air had decreased in Mumbai over the past years. The housing problems that needs to be addressed and the accessibility to the post, which will allow for a better maintenance of the deployed unit. The graph shows the current scenario levels of air pollution and the amount of air pollution aimed to the clean with this unit deployed. In our studies of adapt is scripted space, we looked at to collect detailed and anthropometric and motion data for a organic design application.
One of the main drivers for our thesis is algae. The reason why we chose algae is because it has a high carbon sequestration capacity, it has rapid growth, minimal land and water use, energy production, and it's environmentally safe in controlled systems. The way we want to integrate it with our project is to have algae panels integrated on the outer shell, which will allow the unit to be on water at all times, and which will also help us to have closed-loop systems where the algae can be treated on the unit itself. Our research showed us the way that algae effectively starts to grow on its own and how we can actually treat algae and create further substances like biofuel, which can be used to power the unit at further times. The important part about understanding about algae is that there are different efficacies involved with it. So the different types of waters that you mix with algae gives you different salinities and capture different amounts of carbon at different times. The efficacy that matters the most to us is the one with saline water, which is able to capture 0.14 grams of carbon in a day. We looked at case studies where we saw that algae has been previously used in facade panels, and we took inspiration, and we looked at the mechanical systems to understand how we can implement it within our own thesis. As a study during the time of our thesis, we looked at different materials to understand how materials can be implemented in a better way and possibly define the materials that we effectively use for our unit. We did a case study on carbon fiber where we were able to water jet carbon fiber down in our labs and cut down intricate shapes, which allowed us to achieve bendability within carbon fiber and not straining the fibers too much. We took inspiration from glass blowing techniques, which have been practiced for a long time in the past couple of years. We took inspiration and we started creating our own set of 3D printed circles, where we have a very thin membrane of 0.2 mm supported by structure within it of 2 mm. And what we effectively started to do was, using a heat gun, we started to heat it up, and using a blowing gun, air gun, we were able to inflate it and achieve inflated surfaces with minimal curvature of 0.2 mm. These are some of the results which we achieved with the PLA TPU. We also looked at silicon as a material which we wanted to explore. We were able to expand it and make it buoyant in water. We looked at different shapes and different types. We effectively also self-strained the silicon, where we were able to effectively make it, we were able to achieve buoyancy with silicon and 3D prints when we combined them together. The next exploration led us to exploring 3D printed PLA and inflatables together. In this particular experiment, we started to explore with PLA in boiling water, where we exposed the boiling water to a certain temperature between 75 to 90 degrees, and we dipped the PLA within boiling water. We made an entire catalog of models, which effectively in the diagram shows that we have a thin membrane of ranging from 0.2 to 0.4 mm, then a subsequent support structure, which is around 2 mm, and then we have a top membrane. This allowed us to inflate the bottommost membrane of 0.2 mm, and the support structure would not inflate, allowing us to achieve different patterns. This is how we effectively cataloged the entire process, where we boiled all the inflated models in boiling water. These are some of the interesting results that we were able to achieve, where we effectively got a 0.2 mm surface to have a lot of curvature, which won't be possible if we just effectively 3D print it. Yeah. As for our prototyping, we looked at origami, crease folding, where we did an entire catalog in order to understand volumes from single surfaces. We also looked at curved crease foldings and the volume that we can achieve by deploying these. We looked at simulations, which we did digitally. We looked at hinge systems where we created 30 and 60 degree hinges which are able to bend from a single point. We also looked at kerfing as a way of transformation, where you apply paper cuts strategically in order to achieve volume from a single surface. We looked at kerfing patterns in different shapes and different amounts of cuts and densities. These are some of the results that we achieved. And then we carried on with the same exercise and we achieved better results and more amount of volume. Coming to the unit morphology, we started with the idea of having a core and having algae panels on the facade on the outside. We started developing the unit effectively by pulling grid points off to understand shapes and achieve volumetricity within plans. We started looking at sections and seeing over a period of time how does the section change and how does it start to affect the plan over a period of time. We looked at sectional studies and variation in section over a course of time where the unit, when in a mobile state, would effectively have a change in section. By the end of half of a year, we effectively came to the idea of having a sinusoidal movement shape, which would be the mobility driver and effectively the design driver for the unit that we would want to further develop. When we started looking at the design development, we wanted, since we are dealing with water, we effectively started looking at the bottom half of the unit, which is called the hull. We wanted to add a very performative aspect to it and achieve and extract the best shape that we can out of the research. So we started to analyze it in wind flow testing and also fluid dynamics, and we were able to understand that the best possible shape would be a front round profile. And we also did a combination with another typology of a hull, which allowed us to get the maximum performance. We looked at, here we're looking at the top half of the unit, where we started looking at skeletal structures to be combined with the unit hull. And we were able to achieve a certain set of skeletons. And then to deal with the buoyancy, we went back to the site to understand the site location much better, where we categorized the site over the year in 3 different parts, which is pre-monsoon, monsoon, and post-monsoon. Since the site has a condition of monsoon where the water levels rise during that period, that allows us to look at the rising levels of water over the course. So we looked at all the 3 seasons to get the exact conditions, and then we simulated the units within water to understand how buoyant the unit will be effectively. We looked at it in an axonometric and a plan view, and we extracted the data to give us the first set of diagrams where we were able to draw out a line and understand the amount of the unit that will be effectively underwater. Based on these diagrams, we started looking at ways of actuating the unit and ways of extracting a shape which can be used to develop the design. These are a set of diagrams that we effectively started to make once we got the buoyancy results out. These are the initial sketches of designing the central monocoque of the unit, as we could say. This is the first iteration of the monocoque, which led us to designing a additive section, and so this gave us the first iteration of the unit. It looks a bit complicated, but yeah, this allowed us to further simplify the unit and get it down to more structural elements, where we looked at these diagrid panels and to get a more even and a cleaner form of the unit. Comparing the two, we realized that we still need to make further adjustments in order to achieve a better looking, better performative unit. So we started looking at the section in a way to understand I'm sorry. We started looking at the section and to understand the different layers that we'll be needing. And these studies allowed us to look at the interior plan as well. So we were looking at a lot of different things at the same time. We looked at having a layout within the unit, which also helped us to drive the design further. We started looking at actuations post our second iteration, where we were trying to identify the possible movements that the unit can effectively do in order to achieve better mobility. The third iteration of the unit came from the idea of simplifying the diagrams even more as a geometry. And based on that, we came up with the third iteration, which effectively had 3 parts of the structure, and the structure would effectively be able to move. This wasn't possible due to a lot of structural constraints that we had, which is why we moved on to developing the final unit that we have currently, which is also the living unit. So this is a highlight of all the design studies that we effectively did that drove the design for the living unit that we currently have. This is a glimpse of the unit that we've currently designed, the living unit. The views, the front, the back, axonometric. This is essentially the living unit, the habitable unit where people can effectively live inside. This is the plan, the open plan axonometric, allowing us to see the different areas within the unit that have a cockpit, a washroom, kitchen, the bedroom spaces, and the common dining spaces. The unit allowed us to have a space on the outdoor, which allowed for better connectivity between 2 different types of units. These are interior views, interior shots of the unit. We also have a look at the plan and the section for anthropometry data, where we achieved a height of 2.8 meters within the center. So the design strategy for the mobility is effectively in 2 parts. One, where the fins that you can see on the side, when they're flat, they're effectively in a shared state, which is when they're flat effectively. And in the second state, they go down by 90 degrees, which allow us to achieve more stability within water during the monsoon season. And in the third graphic, you can see that the fins effectively move in a sinusoidal manner, allowing the unit to move from one point to the other when the entire configuration needs to move. So the 3 states of mobility effectively, based on the transformation that we have within the unit, is the mobility mode, when the unit has to go from a certain point, from point A to point B. The other is the sharing mode, when 2 different units connect to each other, the fins go effectively flat out, allowing 2 different units to connect together. And the third is the stability mode, where the fins effectively fall down flat by 90 degrees in the high monsoon season. So once we developed our unit, we were very thankful to our tutors, where we were able to collaborate with Stage 1 and create a 1:10 CNC section model, which we wanted to cast. We wanted to have carbon fiber as one of our main elements of the unit design. So this is a video that shows the entire process of the CNC milling. So the design that we effectively created was milled on a 5-axis CNC machine. The results were pretty neat. We've got them out here as one of our models, which we casted carbon fiber over. So we have 2 pieces. One is the top part, and one is the bottom lower part, which is the hull. This time lapse showing the, sorry. Yeah.
So in order to maximize the absorption of carbon dioxide, we have planned to put algae panels on top of the unit at the center of the spine. So in order to increase the surface area, we thought of piping the panels and maybe also adding a scale on top of the panels so that we have like maximum surface area. So these are some of the experiments that we did for the scales. These are some of the geometries that we have tested out, and in these we chose an iteration of geometry 2. These are the iterations, and we tried to do these experiments with laser cutter and 3D printer, and these are the settings for those. These are the geometries and their actuations, and this is the geometry that we went forward with. This is like how the scale is supposed to move, and these are the piping designs.
So the idea of the panel effectively, as the first iteration was pretty simple, where we were able to maximize the amount of piping volumetric area that we have in a given shape. The idea of having one air inlet, which allows the carbon dioxide filled air to go through the algae, and an air outlet, which allows the clean air to come through. In this iteration, the two different colors signify two different sectors of the algae. One which, the one which is light green, is effectively just the fresh algae growing sector, where fresh algae is growing and it is passed on to the second sector, which actually cleans the carbon dioxide based air. In the exploded axo, you can see the way that the panel would effectively come together with a curved acrylic bottom, a diagrid attached to support the pipes to the entire structure. In the second iteration, from the first iteration, we realized that we need a lot more inlets and outlets based on the factors to control the amount of carbon dioxide we're actually able to clean. And also, this iteration had an outlet for slug, which is what you get from the algae after it finishes its lifespan. The slug is also used to produce electricity over a period. These are some of the results that we achieved with the algae panel. Coming back to the unit, so in order to understand connection between the two units, yeah, we looked at different mobility formations. So the formation when the units are effectively in mobile state and have to move from point A to point B, they start to have a cluster which is in a straight line formation. And effectively, when the units have to come together and form social formation, they form a radial diagram. There are different unit typologies in order to understand our collective further. So we have a habitable unit, which we've shown. We have an inhabitable unit, which is also called the covered farming unit, effectively, which harvests algae. And we have an open farming unit, which is effectively a walkable algae surface. So when all of these units effectively connect together, they form this entire, the collective that we effectively are going to be explaining. We also have an energy unit. And here we show the deployment of these units. So as in the first living unit, we show how the unit effectively moves. In the other units, we have algae panels that effectively go down by 45 degrees and are able to clean water as well.
So for the collective, firstly, we looked into this very compact mode. We have designed different iterations of the configuration. And we have one living unit with 20 other units of farming unit with canopy and without canopy. The farming unit with canopy could provide the shader for people to have. And we also have energy unit to extract the slug from the other units and provide biofuel to the city. And then we looked at this algorithm differential growth because it could achieve maximize continuous line in a constrained area, which could be used in the non-monsoon season of our site. So it has 100 units in one community. And the relationship between the farming unit and the living unit could be two mode. First could be the managing mode. So the living unit would moving around outside of the farming unit, and the people could get access to the farming unit. And then there would be a guiding mode. So these 20 units could get together in a cluster. Then the living unit could guide the direction for the farming unit. Then they moving to some other places. This is 4 steps of them. they split first, then combining into the guiding mode, then getting into the compact mode in monsoon season. So this is our more in detail research of our site. We're looking into Thane Creek, which is a suburban area of Mumbai. So because the wind direction, so this place have a very severe air pollution and also quite severe water pollution. And we avoid the very busy ship line traffic area and the very shallow area to place our units with 82 kilometers. This is the comparison of the site plan of our communities. So in monsoon season, the right side from June to September, the units would move to the shoreline. At this time, the air pollution is not very severe, but the water pollution is quite severe. So they get to the shoreline to clean the water. And this is a simulation of our how to, in the middle is how to we drop our units in this area. And we drop this from the 5 ports based on the site and avoid the middle, the lights is traffic for other boats. And the right side is for the moving in monsoon season.
So yeah, lastly, we would just like to demonstrate the protective mode, where the units effectively move towards the shoreline when during the high monsoon season, when they're in a community formation, they start moving towards the shoreline during the high waves of water. And yeah, this is how we would like to end our presentation with a screenshot, a money shot of the units being deployed in water of the algae world that we're trying to make. Yeah, thank you. If I can, I would like to explain show you some of the models that we have made. So we started the initial explorations with carbon fiber, where we looked at, where we cured carbon fiber within our own lab, and we used strands of carbon fiber and a single layer of epoxy, where we were able to achieve bendability, and there were minimal deformations. These are our results with TPU, where we scored TPU in certain ways in order to have these pipes. The negative parts are effectively where we fill algae up with. We did an exercise of scoring acrylic, which we used for our first panels, which allowed us to have different intensities of light shown through the algae. This is one of the iterations of the pneumatics that we did combined with the algae panel. The first iteration of the algae panel, where we looked at achieving maximum piping within a given shape. These are again pneumatic-based inflations of the TPU scored sheet. These are filled with foam inside to show the inflatables. This is the second iteration of the algae panel we did with the piping and the TPU on top. And this is effectively one of the iterations of the panel that we are using on our unit, which is filled with algae. These are some of the skeleton structures that we initially looked at when we were designing. These show the design development of the units that we did over the course of our study. This is the living unit that we've demonstrated over here, which shows the algae panels, the structure and the base, the unit hull that we've effectively designed. These are some of the interiors that we managed, the initial iterations of the interior that we did. And these are our inflatables that we had shown, where we were able to effectively achieve 0.2 mm of thickness with boiling water. And yeah, we did this entire catalog. This is our material board, where we looked at different types of materials to achieve these inflatables. We also looked at multi-materials of combining TPU and PLA together. This is our material board for our algae, where we looked at different efficacies of the algae. We also combined them and cured them at different intervals during the period of our study. These are diagrams that show the differential growth process, which we did in order to understand our collective better. These are the mobility system diagrams that we studied, the sinusoidal movements. These are some of the curving patterns that we had explored during the start of the term. These are the hint systems that we developed, so these can effectively, from a single point, you're able to bend them at 30 and 60 degree angles effectively. The tank shows the initial study of formations where they sort of self-arrange, and we were able to understand how they come together as a collective. These are the CNC foam pieces that we collaborated with this company called Stage 1, and we casted carbon fiber over it. This is a 1:10 scaled section of the unit model. And yeah, with that, I would like to say thank you so much.
Hi. I just want to say congratulations. That was amazing, like the amount of work you guys did. You really thought of everything. I was even thinking, I wonder if they thought of this, and then you thought of it. So just like conglomerating them together. Anyways, I just wanted to say something really relevant that's happening right now is obviously what's happening in California, as you guys have all seen. And I was thinking, this disaster is bigger than Manhattan. It's humongous, and I was thinking, where are all these people gonna live? And this could be like an incredible solution, like people living on the water, but then there's the obvious questions of like the tide. I don't know if this works in like, I don't know, is this a real application? Like people can live on the water, and I'm sure all those millionaires aren't gonna be happy about going from their super house to a small house, but maybe it can be like a refugee and also like a water cleanup at the same time, because pollution is very high in LA. It's mostly in the air, you know. But I was thinking, what about things like, just like, because if we're talking about the size of Manhattan into the water, then you're talking about like a city grid, and you're dealing with traffic, and then just a basic thing like sewage could get very polluted, although maybe you turn it into algae and put it on your roof, I don't know. But I love the concept of it, and then, you know, I'm always in the mind of like making things real. So it's such an incredible concept. Like, can we make it real? Could this be a solution for all those displaced people right now? Like, I don't know what's here. I don't even know if people live here or if this is just temporary. Does anyone want the mic?
Wonderful project, absolutely sensational. A wonderful marriage between nature and our various damages we're doing to it. And it seems to be structurally interesting, technically interesting, chemically interesting, ecologically interesting. It's a very fine marriage of all these things. And it is really sadly needed. We need to be thinking about things like this all the time. I think it's a masterful piece of work. You've covered a huge amount of area. You've learned a lot during the process in your various explorations and studies, and it's come together with an idea that is viable, and one can imagine islands of these communities appearing. What I really love about them is they can adapt, they can change their location, they respond to seasons, they respond to the huge shipping route system into Mumbai, and so on, and they adapt all the time. It's almost alive as a concept for people, as well as being a live concept for the algae. I think it's absolutely delightful, huge amount of work, and really seminal stuff. It's the sort of thing we should be thinking about in terms of the planet at large. It's really a great project.
Thank you so much for this very complex research. What I want to say is that from the very beginning, from the statistically good research to geometry research, model research, technological connected with ecology, it is really deeply in all details. And thank you for that, and your team and mentor for support this amazing work. Just small, my impression that I want to see these results on the other medium in architecture, not just about typology of units, ecological units, living units, etc. I really want to see the results of this experiment and this type of project on, for example, facades in architecture, roofs, the other parts of urban situation, because pollution is a huge topic these days, not just in the ecology systems, even in architecture. So thank you very much, and please think in the future to use these results in other situations. Thank you.
Thank you, guys. I'm very excited to see that the work on photosynthetic architectures is thriving and moving forward. I mean, we've been researching on this topic for the past 20 years, so I have a lot of feedback that I would like to give you, also very much on the technical level, but maybe this is not the right time. I still invite you maybe to check the book we published last year, which has a kind of white paper collecting everything that we have done. And I have to say that I really believe that from the technical and technological point of view, it works, it can work. We have done it already several times. So I think in that sense, I don't see any issue. I think what is maybe more interesting in this project, and for me also fascinating, is to look at it from the kind of infrastructural point of view, which is probably what you also, guys, have done the most, when it comes to cities that are dealing with flooding and with rising sea levels. And algae, of course, they exist in many different species in every water body. So like a flooded city is essentially a biologically active city. We call it urban microbiome, right? It's a kind of a layer of nature that is maybe hard to see with naked eye because it's microscopic, but it's extremely active. And like you said, these organisms are extremely photosynthetically active. And so if you think photosynthesis, it's almost the reverse of fire, right? I mean, our society is based on burning fossil fuels mostly, right? And photosynthesis is the reverse of that process. Like, when you burn, you kind of release carbon dioxide, and photosynthesis sucks it in, use it as a food, as a nutrient. So in a way, I think what you are imagining, it's for me not simply a kind of new kind of architecture, but really a new kind of infrastructure, perhaps a new way for society to inhabit wet cities or cities that are flooded, and in a sense to invent a kind of wetware, an infrastructure that is alive and photosynthetic and can really bring about a new form of civilization that doesn't need to burn everything it has to survive and to feed its infrastructures, but actually the infrastructures themselves becomes alive and photosynthetic and counteract these effects that are in a way causing the flooding in the first place. So it's really about establishing new type of societal patterns and feedback loops that may lead to potentially a new civilization. And some people call it a new industry 4.0. You can call it in many different ways. But I think for me, the unit is almost like a symbol, of a new way of inhabiting the urban wetware and essentially imagining a new civilization from the bottom up, which is very ambitious, I guess, as a project, but also something that you may want to dedicate your entire life to. And when I was here doing my master, I think I kind of really left with this ambition, like, and 20 years later, I'm still at it, and I'm no way near the end. And I think that's probably what is exciting about this program, is that if you really believe in what you are doing, it's a project for a lifetime, and and there's no better way to live, in my opinion.
I mean, yeah, just to add, I think it's is amazing research, right? I think you touched on so many topics that, of course, some of them I think they didn't carry through, but they were very interesting. And I like the way that you developed also from the physical to the digital. There was a lot of exploration that I was quite interested, like the origami, that I think it didn't make it through too much of the final result. And I think, well, one aspect, because I think overall, I think it's very impressive. And as everyone said, you touch on so many topics. The only part that I feel that I want to focus a little bit more on the unit, right? That I think when you talked about the wind directionality, the orientation, how the water flows into the area that you chose, right? And then you end up with a almost fully symmetric component for unit. That's the only part that I think that when you start tying it into, you are living in there, you're responding to how the sun will hit your solar panels, your panels, how obviously the structure has a basis for symmetry, but everything seems to point nature is not symmetric, right? So how do you respond to the most of these parameters? I think there was a little bit more of those sort of initial exploration that could have carried on to inform even to a higher degree of design sensibility to create a more orientation-based design and then living-based design. And then when they aggregate, of course, the base needs to be that you can cluster them together. But how you live in these units, if they're actually for living for periods of time or longer period, they could have been even more sophisticated designs if you could argue that there is a sense of orientation in how they cluster, how they orient towards the positioning. And I think that would just be an added element to fully have touched on every single aspect of the research, which is really quite commendable. Yeah. So well done, congratulations. Yeah.
I think there's more microphones. There's 3 of them, but here we go.
Thank you. I think for the time that you had, and it's obviously an enormous amount of work. The one comment I have is when you start your presentation talking about self-sufficiency and fighting pollution and all these big topics, then what's missing, I think, is that you could have put in points within your deck where you're proving those claims, right? And measure, okay, what actually is the impact on pollution? How much energy do we actually produce? If you say, it produces energy for the city, I want to see a number, right? It's just, I think it's the right context, right? And you should frame it in that sense. But then at the very end, I felt like it would have been nice if you would have not proven, but attempt to, do a bunch of calculations of how much carbon gets sequestered, how much energy gets produced, how do I deal with these things? I think that's just from a pure presentation narrative kind of point of view would have been very helpful. And then the other thing that in a further study, and this is not a criticism because you've done an amazing job, but I was very curious to understand how it actually relates to the land. I mean, people will live on the water most of the time, but they also have to go to land, right? and so that interaction is actually quite a, how do they travel? What is there? Is there a little dinghy? Is there what? How do they get from one place to another? So, but in general, I think it's an amazing piece of work, and as it was said before, it is one of those, maybe all of the projects that we have seen so far. Yesterday as well, they all lend themselves to become lifetime projects, right? Because they are so complex, and it's impressive, how many doors you have opened, and now one could go deep into each of them for the next years.
Just a very brief question to continue on your point. I think you have a great opportunity here to also explore the scenarios of how the system evolves, because you have the farming unit and the living unit and the open farming. It's interesting to understand what drives the percentage of how many farming versus living units are going to exist and how the system evolves over time. And that comes back to the point of the interface with the land, how much energy is produced. So it could be interesting to, as a next step, to think about kind of what these scenarios could be like, and what would be the main purpose of the system? Would it be more energy generation, and the living is for maintaining those farms? Is it actually a living community? And there's not one answer, depending on the situation. And I just want to commend you of how expansive you were with the material exploration and the fabrication processes that you attempted and tried and tested.
Yeah, well, I mean, you came a long way and made an impact, so congratulations. You bring it home also through the visualization that this is something we can imagine. I had a few questions of thinking about it, you know, being engaged with it, what I would develop it and what would be the next step for me. One of the things where there's a kind of default, you've been talking about the unit for a long time, and then sudden we had the farming unit, the energy unit, and they were just derivatives. The same hull, and that, I think, would have deserved more engagement and thought. These are distinct, so the farming units could be much larger. They are really so effective. If you have to calculate it, you probably could possibly, in relative to what these farming units carry, they have these kind of sheets of algae, densely packed, versus a kind of panel with a thin kind of tube. If you had figures, you would have realized that the panels on your unit, on their living unit, is more of a symbolic gesture, quantitatively, and to some extent maybe obstructing, you know, taking living with this seriously. I would have looked again at the living unit, and it's great that you have now some outdoor space, but I would further, and what is interesting, the question that wasn't clear, these farming plates, whether they could be outdoor space where you can kind of walk on top. I think you can. It would be good to see, because otherwise it becomes incredibly possibly claustrophobic. The energy unit, and they have a greenhouse also. There you can go in that greenhouse. It's another way of socializing and being. So that's very important to take seriously. I mean, when Dara said, you know, this is Manhattan scale, which is what you're doing there, or big, you know, in the Bay of Mumbai, and it becomes fluid and liquid. But we need to consider more these, let's say, how do you sustain life actually on that scale? So the unit itself needs to become also more generous and have a larger exterior space, open up more, because we've been thinking a lot of the seasteading kind of concepts where this is for other reasons. You're going out, and there it's clear that you really have to invite. I mean, this is not a scenario of, you know, people who sacrifice their life for the sake of the planet, but they still want to have a life, a great life, like Paolo just said. He's, you know, Marco, sorry. You know, so there's something missed. And I think on the design, I do think there's very beautiful studies, very suggestive. For instance, the pulsating manta ray, and, you know, or the earlier studies of the carbon shells and the intricacy of the webbing and let's say reticulated shells. You somehow simplified it, in my view, way too much at the end. You know, let's see, compare, some of these were still kind of, you know, modern design artifact. We have like these kind of cycling helmets. You feel there's a kind of more organic and advanced, and these are technically refined and optimized structures with topology optimization and fluid dynamics. Fluid dynamics also wouldn't allow you to have the second symmetry axis, by the way. So I think there is, I don't know how it evolved out of all these studies, and there's all beautiful richness. So I think you made a maybe strategic mistake of placing this in front of me, so because that's, you know, the culmination is not the right culmination, but otherwise I think this is all there and can be brought home, and congratulations.
Yeah, thanks for the comments. I mean, I'm really aligned with Mike's and Marco comments, but also in general, all the comments of the audience and the crits. I have to say I'm not too much aligned with last comment from Patrick. I think, you know, like we actually tried to enable simplification of the geometry to, for technical reasons, to be able to implement the panels. At the same time, also the geometry itself of the units, it's driven in a way from the fact that it needs to be able to cluster, interlock, and generate a large array of units. So some simplifications are based on technical constraints, some other are based on the fact that we were aiming to have like a really large-scale intervention proposal, and therefore like being able to cluster and let's say merge the units in a very efficient way. I have to commend the team. I mean, they came really a long way. They really did a lot of research on the materiality, on the prototyping, as per Anasia's comment, and I think many of these elements actually didn't also come true completely on the final proposal, but that's fine. I think it's you know, the proposal is an open question and is also trying to inspire perhaps new solutions, you know, as Marco was mentioning as well, like this idea of having an infrastructure, you know, designing an infrastructure, but a soft one, and a mobile one, an adaptable one, that perhaps can contribute positively to issues that are in a way more and more like impacting the life of highly urbanized areas. In a way, I think what I also want to say about the team, I mean, they take on really a complex task of trying to deal with pollution, trying to deal with extreme climate conditions, and at the same time also addressing this issue of being productive and trying to be in a productive and proactive way to repair something that is happening on highly urbanized areas, and at the same time dealing with the water urbanism issue, which, by the way, it's something that it's already happening in many areas, also of the Mumbai Bay, but you know, trying to implement technology in a way that perhaps can support life and enable perhaps new interfaces with the current urban pattern. But I agree, you know, the interfacing and also like the way perhaps the project is visualizing these potentials of using the platforms actually as a you know, kind of adaptable and flexible spaces for different programs. I think that that is something that perhaps I would try to visualize for your book if you have time in the next few days. But thanks.
I'd just say one thing. Well,
I think it's a moment of joy. We're sitting here. There's an incredible driving idea behind this project. It's quite extraordinary. And it's applicable in a very large number of places around the planet, in places which really need it. And it is a fantastic opportunity. Here we are sitting in an architectural studio looking at something which is a worldwide issue on a much bigger scale. It's fantastic that the AA has involved itself with it and picked up the baton. And I think that's the most significant thing about it, is that the school is there contributing to a worldwide issue with creativity, with all the reservations everybody said, but never, the driving idea is quite fabulous.
Yeah, maybe just to conclude with all of the comments, I think the conversation around the project is, I think, probably the most meaningful thing, which I do think that the conceptualization, the idea of thinking of this as an infrastructure, I think you've gotten a lot of important comments that I think should also unlock, I think, some of the issues. I have to say I support some of the design challenges that also Patrick is speaking about. I think there are a lot of issues, there's a lot of complexity that you're touching on, but it's sketched. And I do think Marco's point is an important one to take away, which is that if you really believe in this, and I think that there is a promise that's kind of shared here in the reception and the conversation of the project, then you will approach that in a very open process. I think that there's been a design part of the project that has been very linear, that's brought you to this place. But I think in terms of continuing it now, every one of these aspects would need to be completely interrogated and blown apart. If you focus too much on the design of it, like literally where you got it to the unit, I think you miss the opportunity to really see this from a much more holistic and I think more ecological and bio-relational point of view. So I'm very happy that the conversation focused on this part of it. because I think that there are a lot of technical issues that you guys really need to deal with, which, to be honest with you, are not just technical solutions. And the aspect of what life means here, I think, should be also qualified. You call it a living unit because people are supposed to be on board. The living unit should be much more about how this is an infrastructure to support, I think, all of that city life, the urban life. When I look at the animations, even if Pierre says that it's an urban project, it looks like it's, you know, a series of villas in a very bespoke nature setting. And I think this is the tension in the project, where I think the complexities of the city will just be, I think, further information and data for you guys to really try to use. And I think Jan's point also about, you know, trying to quantify that and play the numbers out is really important, because they help you create design decisions. You know, like when Patrick says about the larger tiles or the family of other support systems, each one of those has to have the same attention that you've spent on the living pod, if not a lot more. So I think it's a really good way to start the conversation. It's, I think, a nice way for you guys to conclude this. You don't have time for your book because it needs to be submitted today, but just to sort of put that on there, because the powers of B will come down heavy on us. But anyway, I think it's a great way for you guys to conclude. Thanks so much.